So we finished 2.2 with histograms, and right now we're getting into 2.3 and 2.4. Today I want to try to get through into 2.5 and maybe a little bit past that. We'll see. We'll see how far we get. I want to real quick review, not review, let's talk about percentiles. I've got a little handout for you guys to work on, so it's not just me up here yapping away all the time. So, let's I talked a little bit about this, but just to remind you guys, if you take has anybody ever heard of the ACT and the SAT? Sometimes they'll give you your results in terms of percentiles. What a percentile is, if you got the 78th percentile on your math SAT, that means you scored better than 78% of the people that took that version of the SAT. Why is that a more fair way to do things? Do you understand that every time they give the SAT, they change it? Yeah. Why must they do that?
Maybe they'll cheat.
Yes, because you do have people that have photographic memories, and one thing I would do if I had photographic memories is to make some money off of it, right? So they have to change the test. Could they randomly change the test and make it generally harder? Not on purpose, but couldn't that happen?
Yeah.
Wouldn't it be unfair then to have pure grades compared to people that took the easier version of the test? So when you have that kind of situation, you want to use percentiles because they measure relative to the people that took that test. Yes? Okay, maybe. So maybe somebody got more questions right on the easier version, but when you compare each other to the people that took your version of the test, you actually have the same relative score. Does that make any sense? Okay, I like it. So every single percentile in the universe means the same basic thing. If I'm in the 78th percentile, 78% of all the other data is below me. Always. That's what a percentile means. Okay, I like it. It's pretty with me. So if you had the 12th percentile in terms of money you had to pay to fix your car, what does that mean? No. Just directly when I say 12th percentile, I know what you're doing, but just use 12. If you're in the 12th percentile compared to people that said how much money you had to pay to fix your car for a certain thing.
Paid more than 11%.
You paid more than 12%. Yeah. Okay. You guys with me? You paid more than 12% of the other people with that same repair requirement. Are you happy? You're happy? But yeah, hell yeah, because like you were about to say, you paid less than 88% of everybody else with that same thing. Yes? Okay. Maybe you have a mechanic in the family. There are certain people that have as friends and family, lawyers, doctors, mechanics. It's really good to have friends or family that do those things. Yes. When I was before I had real health insurance, I was working part-time, but I worked at a hospital. And I didn't do this a lot, but if I had a sick, I say, hey man, and they would go to their little sample thing. They'd say, okay, Jeff, take 3 of these every day. Let me know how it's going. So I didn't have insurance, but I was working at a place where they would kind of look out for me. So that's what they keep in mind. Okay. Gotta game the crazy ass system we have here. So let me give us some concrete data to work with. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this could be ages of people. This could be bowling scores for people that are playing for the first time, right? You guys kind of with me? Almost doesn't matter what the data represents. What's one thing about the data that I've done that's nice? Put it in order. So it kind of makes sense. If I'm ever trying to calculate relative position of a data point, I need it to be in order. Okay. So can somebody tell me a guess as to the 80th percentile of this data? And the way we represent the 80th percentile, because math people don't like to write a lot, is P80. So if you see capital P with a number below it like that, subscript, that's that over percentile. So you all know what 80th percentile means. Does somebody have a guess as to what the 80th percentile is? 31. All right, so one guess is 31. Anybody else have a different guess?
34.
34 is another guess, okay? Any other guesses? Can you explain why you thought 34?
Because I'm thinking like if 45 is the maximum top number, then something closer to 80%.
Oh, okay. So you're sort of doing it kind of visually like 80% should be close to the top and not the top.
Yeah.
Okay, I love it. So you're more kind of feeling it out.
Yeah.
And I'm sorry, you said 31. Why'd you say 31?
There's 10 people in the sample. So I just took
And 31 is the,
8.
I love that logic. That kicks so much ass. Now, unfortunately, you're both wrong, but I don't blame you. Sorry. Oh man, it kind of sets you up there. I'm a math guy, I'm evil, so I enjoy doing that. So, 80th percentile, it directly means 80% of the data should be below it. So your guess makes sense in terms of that, because how many data points are below 34? 8.
Yeah.
That's 8 out of 10, that's 80%, right?
My fingers.
Your guess makes sense because if I'm in the 80th percentile, what percent should be above me? 20%, which translates to 2 data points, and how many are above 31? 2! So somehow you're both wrong, but you're both dancing around the right answer. So here's the evil part. And again, I'm not grading this shit. We're just learning this, yes? There is a number that has 8 of the data points below it and 2 of the data points above it. It just happens to not be a data point. So if 31 and 34 are both kind of answers for opposite reasons, shouldn't I just take the average of those? Whatever's in the middle of 31 and 34, doesn't it have 8 data points below it? Doesn't it have 2 data points above it? Okay, you stop for a minute. What is the middle number in a set of 5 numbers? Yes, the middle number is the third one, yes? But what is 50% of 5? 2.5. You with me? What's the middle number in a set of 4 numbers? 2. Is there a middle number?
2.
No. What's the middle number? Is it the second number in the middle? Is that in the middle? No. That's not the, wouldn't the thing between the two middle, wouldn't that be like the middle? That's the middle, yes? So, the middle number would be like the 50th percentile. It should have equal amounts above and below it. If I have an even number of things, then the 50th percentile is not going to be any of them. It's got to be between 2. Maybe. So, here's the exact recipe you always follow to get any percentile. Okay? There's 2 steps. The first step is kind of like related to what both of you guys did. You did it in a way where you felt it out, which kicked ass. And you did it in a more like mathematical kind of thinking. I love it. Both of those things are beautiful. If I want to get the 80th percentile, about how far into the list should I go?
8 numbers.
If it's 10, but I mean in general, what if I had 8 million numbers? How far into the list should I go? If I want the 80th percentile, what percentage of the way into the list should I go? 80%. So the first step is always the same. Whatever the percentile I want, I take that percentage of how big my list is because of what you just said. This is what you actually thought. Let me go about 80% of the way in, so it looks like it's probably 34, right? Okay. Ballpark, exactly. Okay. So first step for P80 would be, what is 80% of 10 in this case? Why is it 10? Because I have 10 numbers. Will it always be 10?
No.
Hell no. Okay, beautiful. What is 80% of 10? 8. Just like what's half of 2? I'm sorry, what's half of 4? 2. Is the second number halfway? No. What did we have to do? Didn't we have to average that with the next one to get this guy? Yes. Yes. So, if I take a percentage of a number, 2 things can happen. I can get a whole number, or I can get something else, a decimal, right? If you get a whole number, you average that one with the next one. So the first step, the percentage of your list. I want to go that far in. That makes sense. If I want to get a 20th percentile, I want to go about 20% of the way in. So that's the first step. We got a whole number. That means average the 8th and the 9th numbers, and that's the answer. So your 2 steps are, where is the answer? So now we know we have to average the 8th and the 9th. And then step 2 is go get the answer. What is the 8th number? That's right, kids, 31. What's the 9th number? 34, and then you average them. Now there's other ways to find the middle of 31 and 34. This is the direct way. But somebody else can tell me just what's in the middle of 31 and 34, exactly in the middle? 32.5. And of course, if you do this, you'll get 32.5. Okay, let me stop for a minute. Do you guys see the reasoning behind that? Just the fact the 8th can't be the right answer because it only has 70% below it. And the 9th can't be the right answer because it only has 10% above it. So I have to go for 2, and then that's... Now, what do you guys think? Now, is this a very big collection of data? No. There's going to be a lot of repeats then, because there's not a lot of options, right? The 81st percentile will be the same as the 82nd percentile. It's just, we can't get that detail with a very small set of data. Okay, so percentile is still sort of a rough estimate, but it's a little better than just sort of like looking at it and getting a feel for it. Okay. So can you guys take a minute and figure out the 25th percentile for this data? Don't say anything out loud, just try to get the 25th percentile. If you need to borrow a calculator, just bring an ID up. I can give you a calculator. You might need one later. Hopefully you don't need too much right now. Is it just me, or is the warmth overcompensating in here?
It's great.
It's good?
It's incredible.
Okay. I'll leave it on.
I'm real cozy right now.
Yes, 25th percent. I won't touch it. I always run a little warm, so I gotta check. So 2-step process, right? So if you want to put that in the calculator, 25%, you move the decimal back twice, it's 0.25. And multiplying by 10 is easy. What's 0.25 times 10? 2.5. Our number system is based on 10 for some reason. My pinky won't cooperate. So when I multiply by 10, it should be easy. I just move the decimal over once. Now, we just got a whole number here, and what that means is we averaged that one with the next one. If I get anything else, what was the, what's half of 5? 2.5. But what's the middle number? 3. The third one. So if I get a decimal, any decimal, you round up and you take that number. Even if I got 2.1, I would round up to 3 and I would take that number. So 2.5, I'm going to round up to 3. So the third number is the answer. What's the third number? 18, done. Now again, with only 10 numbers, 10 data points, there's only so many data points, there's only so many between them. I'm gonna have a lot of repeats. So if I did P26, I would get 18. So percentiles mean a little more when you have a larger set of data. Okay.
The answer's 18.
Totally.
Oh, I thought, oh, there it was.
Yeah, so the first step tells you where the answer is, in this case the third number, and the second step is go get that. Yes.
So you
So
don't
we're always rounding up if we get a decimal.
Yes, any decimal you get, you round up and take a number.
Oh, so it would be 17 because there's decimal, it's not a data point on the thing.
Yeah, the third data point was 18. Right?
We're
14,
trying to get
15.
25%, that's why I counted 1, 2, 3, and then I added 15 plus 18 divided by 2.
You do that, when do I average two things? When I get a whole number. When I get a whole number, I average that with the next. If I get anything else, any decimal, I round up and I take that one. I'm sorry, anybody else have a question? You guys good? Okay. Those are the only, are you good?
Oh, yeah.
Okay, those are the only two things that could happen, right? Now let me ask you, even if you don't watch football or basketball or whatever, if 25% of the game is done, you're at the end of the what? First quarter. So what's another thing I can call P25? That's the 25th percentile, that is the what quarter? First quarter, so I can call that Q1. So another name for P25 is Q1. So what do you think Q2 is?
50.
Holy shit. So go ahead and figure out Q2 here, P50. And then I'll show you a shortcut for Q3. Figure out what P50 is. Yes.
Why do we find it pizza?
Say again?
Why do we find it
Because I want to. Why did we find P80? I'm sorry, yeah, because I had to make something up first to work on. Now, Q1, Q2, Q3 are probably a little special. So they're gonna go into something, so there's a reason I'm doing specifically Q2. But I could have asked you P13, P57.
So I would just do that, right?
Yeah, totally, yeah. And if you get a whole number, you average that with the next. If you get a decimal, you round up and take that. So of course, what do you get when you do that?
So I got 5.
5, whole number. So you take the 5th and the 6th, average. Yes.
Oh yeah, because that's what you did on the first one.
Yes.
But if you got like a decimal,
Then you round up and take that one. So you're almost rooting for a decimal because then you got less work to do.
okay.
You round up and take it. So I get 50% of 10 is 5. So I have to average the 5th and 6th. And what are the 5th and 6th numbers?
25,
Yeah, that kicks ass. So what is P20? What's P50? 25. Right? Because the average is 25 and 25 and 25. Okay. Can somebody remind me how far into the list did I have to step to get Q1? How many steps do I have to take to get Q1? What was the first? Do it again.
2,
No.
3.
3, right? 3. How do you go? 1, 2, 3, and I got the answer. Yes. You with me? Really want. So if I have a whole list of data, 25% of the way in for this data is 3 steps in. Yes. From the bottom. If I want Q3, that's 75%. Isn't that 25% of the way from the top? So I could do 75% at 10 and then round it up and bullshit, or I could just go 1, 2, 3, starting at the highest. If I go 3 in to get the 25th percentile, I just have to go 3 in from the other side to get the 75th percentile. Because aren't they symmetrical? If you have no idea what the shit I just said, do Q3, do P75 the same way we just did, yes? But this is just a little shortcut. So let's see what I get both ways. If I step 3 numbers in from the top, what do I get? 1, 2, 3. 31. So I already know, because I'm all neat, that Q3 is 31. If I do the 2 steps, what's 75% of 10? 7.5. I got a decimal, I round up. What's the 8th number? 31. Okay, so you catch up. Yeah. So just a little shortcut. You don't have to ever do it if you don't like it. If neither way makes sense, dear God, speak up, come see me, something. Okay. Yes?
Would that be true if there was 11 digits?
That would be true, period. Because 25 and 75 have to be symmetric to each other, yes? If I go 25 in, that's the 25th. If I go 25 on the top, that's the 75th. Does that make sense? So it will always be the same number of steps. Okay. Maybe. Okay. So, okay, let me summarize what we've got here. What's the lowest data point in our list that we're working on right now? What is it? What's the lowest data point? 14, okay. What was Q1? 18, there we go. What was Q2? 25, and what was Q3?
8.
No, that was where it was. 31. Yeah. And what's the highest data point? 45. So if you, and again, if you don't like sports, you're fine. It's kind of a nice analogy to you. The beginning of the game, end of the first quarter, end of the second quarter, end of the third quarter, end of the game. So it's kind of a way to summarize what's happening through my whole data list. This is going to create a picture that I'm almost certain you guys have seen in some form somewhere. The picture is called a box and whisker plot. That's the name of it. More boring books call it a box plot. But it's a frickin' box and whisker because it's got frickin' a box and some whiskers. So, every single time you're going to graph something with numbers, I need the scale to be consistent. So I want to make a number line where all of these data points have a home. So, for example, I could start at 10 and I want to end at 45 or 50 or whatever. What's a good scale to use? I don't want to go by ones because that would go a little insane. What's a good scale to use?
5.
5, so let's try 10, 15, 20, 25, 30, 35, 40, 45. Okay, that's pretty good. Cool. Scale has to be consistent, and every data point has to live within there. Now, before you go making dots, we're not in algebra. We're going to make a line above each data point. So like above where 14 is, I'm going to put a line like this. Jump up! But you can make whatever sound effect you want. So above about where 18 is, line. Above 25, line. Above 31, line. Above 45, guess what? Line. Okay. Very exciting. The middle 3 make your box, and then the outer ones are where I draw my little whiskers. Has anybody ever seen a picture that looks like that somewhere in your life experience? Yes. This is kind of like one way to represent data. In fact, that's where we are. We're in chapter 2. We're at the beginning of chapter 2 where we're talking about how do I just display my data. Let's see who gets this reference. Anyone tell me what's in the box? What's in the box? Can anyone tell me what percentage of the data, every single box plot you've ever seen in your life and ever will see, the same percentage is in the box?
75.
No. I appreciate you saying that though, because what was this line again right here? This one? 75. So it's 75% below it, yes? And what was this one? 25. So it's 25% below it, correct? So what percentage is between?
50.
Always. So the box has the middle 50%. Is anyone considering transferring to a university or a four-year college? Have you guys ever heard of or looked at, you have multiple guides for colleges, they have the Princeton Review Colleges and whatever. And if you ever do, they always report like the middle 50% SAT scores for incoming freshmen, the middle 50% GPAs, that's kind of like the heartland. And then these are the kind of outliers, the overachievers and the underachievers, yes? Or the people that actually have a life and jobs, yes? This is me over here, okay. You guys kind of with me?
Yeah.
So that middle 50%, a lot of the time we focus on it because we consider this stuff to be more potential outliers. And this is kind of like our heartland, right? Okay, maybe. What looks to be just visually, what looks like it could be an outlier? Does 14, does that look like an outlier? No. But 45, why does it look like an outlier? Because it's freaking far away from where most of the data is, correct? Okay. There is, oh God, I'm just gonna say this really quickly because I'm not gonna focus too much of this. This next part is important, right here. This part right here, there's something called the interquartile range. Can somebody remind me just what the range is? Because the range was the
low, high number minus the low number.
kick-ass, high minus low. And you guys see how that's in my list there? So interquartile range is step 1 in, step 1 in. So the interquartile range is Q3 minus Q1. It's basically how the length of that middle piece, yes? So in this case, so always IQR is Q3 minus Q1. In this case, what does that come out to be? Q3 minus Q1? 13. Okay. So do this for me. This next part is a part I'm not overly concerned about, but I just want you to know this exists. If I take Q3 and I add 1.5 times the IQR, oh my God. So I take Q3 plus 1.5 times the IQR, yes? 1.5 times 13 is what, Chef? I don't know, man. 19.5, I think. Yeah. So I think this is 50.5. You guys can double check me. What that tells me is if there were outliers, they would start at 50.5. So 45 is officially not an outlier. It's not far enough away. So I don't know if anybody was concerned about the fact that we didn't have a specific definition of where the hell outliers start. How do you officially determine what's an outlier? What's so far away you're like, you're weird. Yes? And that is one way. I do Q3 plus 1.5 IQRs, that's the upper range. And if I do Q1 minus 1.5 IQRs, that's the lower range. And that would tell me if anybody's officially an outlier. That's all I'm gonna say on that, because I'm not, just want you to know it exists. So like in section 2.1, you're making stem and leaf plots, and then they ask you, does anything look like it's an outlier? You can just do it based on what looks like it might be an outlier. I just want you to know there is a specific way to figure out if it's technically an outlier. Okay. Love you guys. So IQR, you must know. This is a little extra business. Okay. So here, let me give you this. Oh, by the way, before I forget, do you guys agree that this summarizes my data in a way? And of course, this makes a visual out of that summary. How many numbers are in this list?
5.
So here's the math creative geniuses. We call this the 5-number summary. So if I ask you find the 5-number summary, I mean low, Q1, Q2, Q3 high. Okay. So I want you to go ahead and try these out. Now remember, last time I showed you how to use your calculator to sort these. So now, if anybody else wants to come up, well, if anybody, I don't think anybody's done. If you want to borrow a calculator, you can do that. You just need an ID or your phone or your firstborn. Make sure it's got good battery. Good. Oh, sorry.
The road could come out.
Hey, can I trade you 100 Canadian dollars? Appreciate it.
Oh my God. Thank you. Oh, nifty. Mm-hmm. Thank you. All right, so pretty good. Okay. So try to start this by yourself, and then I'm gonna let you guys check in with people around you. But you can use the calculator to sort it for you. You don't have to if you just want to sort it by yourself. Not sure why you would want to.
You said that here, you just press clear, right?
No, yeah. Hit enter now. Yeah, there you go.
Okay.
So a lot of times it's like you tell it what to do, and then you hit enter, and it makes you do it.
Okay.
Oh yeah, go to stat. It's a huge button for us. Go to edit. That's where I can put stuff in. So just hit edit. Now you can just start putting the numbers into this one. So put all those numbers into list one. So if you're using a calculator, all those numbers should be in list one, yes? Because that's all one set of data. Highlight the list. So I use the arrow key to, highlight the list to go up. There you go. Now hit clear enter. So you gotta tell it what to do and then tell it to do it. Yeah. keep going. Very exciting part of this video. Now, let me see if I can get you guys to agree with me. The math involved here is barely anything. It's the ideas. We're not used to these ideas. So how long have you guys been working with these ideas? Not very long, yes? I'm looking at this like you can tell me how to. You guys got it with me? So you have to eternally get off your own back about. I like to do a worksheet like this immediately after we discuss it so you can start to really process what the hell I said. But you're not supposed to be able to come do every problem like quick. That's insane. You just learned about this stuff. Okay, so sort the data, done. What's the 2 steps for P17?
17% of
Take 17% of 20, right? So this is not always 10, like I said earlier. It's just however long your list is. And I really hope this just makes immediate sense. If I want the data point that has 17% of the data below it, of course I'm gonna go 17% of the way into the list. That's a great first step that only makes sense. And what is that? Got a decimal, so what do I do?
4.
So the first question, the first part of it tells you where the answer is. So this is crazy. The second part says go get the answer. And what was the 4th number?
63.
Yeah. 63. Okay. So P17 is 63. Bam. And of course P72, all the same work. What's 72% of 20? 14.4. I rounded up to 15. And then what was the 15th number? The really nice thing is if you notice down here, it tells you where you are in the list. So the 15th number is 87. Now real quick, isn't 72% really close to 75%? So shouldn't P75 kind of end up probably being close to this? And that's, if you guys have done that part, you got there. Looking back at part B, exactly what does this statement mean?
You scored a 63, you scored higher than 17.
Yes, if you made a 63, you scored better than 17% of other people. Obviously, you're not feeling too great about that. So, a 63 is higher than 17% of the other scores. Yes?
So when you get a decimal, it doesn't apply to 5 and 9, it's not up.
Do it again, sorry. You mean up here?
So if you get any decimal, you always have
You round up. Yep.
even though it's not greater than 5.
Totally. Yeah, and I really want this to make sense. If I get 5.1, 5 isn't far enough. So we round up just to make sure we go far enough in. Percentiles are not precise. There's no way they can be, especially with a small set of data. 20 data points is still small. If I had 18,000 data points, then everything would have its own percentile. Yes? I have a lot more to kind of live in. I got better resolution. Okay, maybe. This is like playing Super Mario Brothers. Not very good resolution. The first generation. Okay. So what about the 5 number summary? The 2 things that are really nice, of course, are the low and the high. Oh shit, what have I done? I've done horrible things to my poor little thing here. What do you guys get for those?
55.
Yeah, 55 and what now? 98. Okay. So those are nice. Those are gimmies. Q1 is the same thing as P25. And then the 2 steps are 25% of 20. What's that? 5. So what does it tell me to do?
Add the 5th and 6th number.
Yes, average. Oh shoot, did I turn this back on? Average the 5th and 6th numbers. I did, look at me. So what were the 5th and 6th numbers?
69 and 70.
69 and 70. So what's the average of 69 and 70? Holy shit. So all day long you can get decimals for percentiles because part of the process could involve averaging 2 things. Okay, how are we feeling? So just to really make this clear, to get Q1, I stepped 5 data points in and then averaged that one with the next one. So I'm gonna apply a shortcut on Q3. Let's do Q2 though. P50, what's half of 20? That's insane. So that means I average the 10th and 11th, yes? What was the 10th number? 73, and what was the 11th number? 73? I don't know. I'm crowdsourcing this. So let's see. 10th number 73, there we go. 79 divided by 2, 76. Okay. Now, if you understand how to do Q1, Q2, you can do Q3 the exact same way you did. The way I would do it is, instead of going 5 up from the bottom, I'm gonna go 5 in from the top. You don't have to do it this way. 5 in from the top is 1, 2, 3, 4, 5. So I'm gonna take, what's it, 87 and 87. So what is Q3? 87. Yeah. And then, yes sir.
You can do that for Q2 too as well, right? If you get Q1, you multiply Q by QX, you get the number. So like, if 1 is 5, 2 would be 10, 3 would be 15, right?
Yeah, well, you gotta be careful because since this was an even number of data points, then it kind of lines up better, but with an odd number of data points, or with a, if I had 22 data points, Q1 and Q3 would have been whole numbers, and Q2 would have been not, or the other way around, I mean, yeah. So you gotta be careful about making too much generalization. You're kind of right in certain situations. So how do I make this box and whisker plot? I want to make a number line. What's a good place to start? You did what now? 20. So you start at 50, is that what people said?
Yeah.
Sure, 50. And then what kind of scale are you gonna make?
5.
5s? 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay. So now I have a place for every data point to live. Yes?
Would it be 50, 60, 70?
Totally. So there's a lot of options, just you almost never want to do by ones. It's a little insane. You could even do by 7s if you feel all nifty about it. Are you with me? So there's several options for your scale. 5 is the first thing I heard. You could use 10. So then I got 55, 69.5, 76, 87, and 98. How do I make my little box, dude? The middle 3, and then I just make my 3 scars. Okay. So I can tell this sort of leans towards 100. Do you see that? It's kind of skewed towards 50. It kind of leans towards 100. So it's not like perfectly symmetric. It's kind of close though. It's not too far off from being symmetric. I don't know if you guys see what I'm saying. The box is almost in the middle. The median's almost in the middle of the box. It's close to being kind of symmetric. Good.
Oh, so you're starting the weights on
So I mean, there's a lot of options. You can start your data. You can start your number line wherever you want to. You can choose the scale. You just have to have a consistent scale, and every data point has to fit. Okay. Okay. So just a little more here. Has everybody got all that? Yes. What's up? How do we get what? Sorry. Oh, okay. So, the most fundamental idea behind percentiles, if I have the 37th percentile, whatever I'm measuring, there were 37% of the things were below that. So if it's the 37th percentile amount of rain on this day, that means 37% of all days had rain less than this. Percentiles always mean that percentage is below that data point. So if on a test, an 80 was the 73rd percentile, what does that mean? If an 80 was the 73rd percentile, that means 73% of all students scored less than an 80. Does that make sense? Now, how far below 80 did they score? I don't know. Percentiles don't drill that far down. They just tell me what total percentage is below that. Yes? Okay. So that's when you say the top 1% of income earners in the United States, way up there. Yes. Okay. Let's not go too far down that road. Okay. Is that better? There are several problems in the homework. For example, a problem might say something like, I was in line at the grocery store and my wait time was the 90th percentile wait time. Right? Could I be happy about that? What does that mean directly? My wait time was the 90th percentile wait time.
But you had to wait longer than 90.
90% of other people waited less than me. I waited longer than 90% of the other people. Yes? Okay. If I feel like it, then I ask for the manager. You guys coming with me? Okay, maybe. Is that cool? You're gonna have several problems in the homework that are basically exactly what I just said. They're gonna give you a situation, and they're gonna say, is this person happy? Interpret what's going on, and is this person happy? Yes? Okay. That's it. Every single percentile in the universe means that percentage is below that. My bowling score is in the 48th percentile. 48% of everybody else scored lower than me. That's it. That's what they all mean. Okay. So let's start to move in the direction of the latter half of chapter 2, which is, yes, oh, you good? Okay.
Oh, sorry.
Which is analysis. The first part of chapter 2 is how do you make visualizations of your data. Histograms, you can do a box plot, you can do a stem and leaf, yes? That's just showing people the data you saw. The next step is the key step. The next step is analyzing our data. So, I have two key things I want to do with every data set. And the first one is to figure out where the center is. So what is something we've already done that kind of tells me where the middle of a set of data is? I love it, kick ass. So what we just did was one measure of center, which is Q2, P50. Yes? Does anyone know the name of that officially? It starts with an M. No? Median. The median. Tell me really quick. Does a percentile give a shit about every data point? Does it take into consideration the value of every data point? No. It is a positional dude. Right? So if I look back at this problem and I change the highest number to 100, does that change anything except my highest number? Nobody gives a shit. It doesn't change where every data point was in relation to every other data point. So percentiles, including the median, because the median is just P50, Q2, they just talk about the position of a data point relative to the other ones. So you guys with me? What does the average do, or what's also called the mean? I think I've used that word. Math people like four-letter words in general, but specifically ones that start with the letter M. So we don't want to call it average, we want to call it mean. To be technical, the word average is actually a word that means the median, the mean. The way we use it colloquially is not correct, but you know, it's okay. So when I talk about average, I want to start using the word mean, because you're going to see that everywhere. So let's do this. You guys told me median first, so let's start there. So the median, it's another name for Q2 or P50. The symbol for it is X with a little tilde on top. It's got a neat little hat on top of its head that kind of will tilt towards you if you say hey to it. Hello. So to find the median for any set of data, I just have to find the middle number. I have to find P50. So for example, just very quickly, we've already done this, but just tell me, what's the median for this set of data?
76. Oh, and that set of data. Oh, I thought you were talking about the last.
Oh, no, yeah, this data here. 2.5. So X tilde is 2.5. Will your answer change if I make this one 5? What is this, Jeff? 500 million. What's the median? If I make that 500 million, 2.5. So is the median affected by outliers? Again, I just made 5 into 500 million, yes? Did the median change? Because the middle is still in the same place, isn't it? So is the median affected by outliers? No. So what is something we hear reported as the median? How do you hear home prices reported?
Median home price.
The median home price. How do you hear incomes reported? Median income. Why do we do that? Because you go to La Jolla, and I like to walk around and go, that's really nice. It's a house I'll never be invited in. You know, maybe you should leave a little room so I can see the view, but whatever, it's fine. You guys kind of with me? Or don't do it. Or do that. I don't know. So obviously, if I reported the average home price, that would be way skewed up because those crazy ass houses are going to pull that down. Home price is expensive, but not as expensive as the average would make it look. So let me do this. Let's talk about the average since I already am. And I'll call it what I should call it. It's the mean. This is our first little baby formula we're going to do right now. First little official formula. I'm going to let you have it on your formula sheet if you want, but it's kind of silly too, to be honest. But it's going to be an introduction to the symbols we're going to use. So if I'm talking about a population, the population mean, the symbol is mu. It's like a U with an extra leg. I understand if you make an M, but if you could try to make a little U with an extra leg, that'd be great. Make an M, you're fine, I understand. You guys with me? In general, in the beginning of this class, a Greek letter is going to designate population, and one of our letters is going to designate sample. Just to kind of be, ooh, population, Greek letter. Yeah. So, can you guys just tell me in English, how do I calculate the average, the mean? Add them all up, divided by
the total.
the number of data points, yes? Or how many there are, or whatever. Is that cool? Does everybody agree with that? That's a good, add them all up divided by how many there are, yes? So I'm going to capture that as a little equation. The thing that mathematical equations do is they're a shorthand way, instead of writing all those damn words, we just want a shorthand way to write it. And that means that everybody else in the universe that takes math has to catch up with all the freaky ass symbols we use to translate it. It's like learning any foreign language. So, the symbol we use for add them all up is the Greek letter S from Greek. We use, I don't know why I said the Greek letter S from Greek, just deal with me. It makes sense because what's the official word for add? Sum, yes? S-U-M, sum them up. So we use the Greek letter S for summing. This symbol by itself doesn't mean anything. It's kind of like Can anyone tell me what the square root of 9 is? 3. Can anybody tell me what this is? Can you tell me the answer?
Yeah, it's
What would you say? You would say, what the hell's inside the damn thing? Okay, so if I see this symbol, it's not done. What's in it? It's saying add what? So add What letter do we use to designate all the values that the data can take on? X. I love it. So add up all the data values. And then what do you think I want to use for the number of things? That's great. Okay. Yes. I kind of led you that way. I want somebody to go W, of course. So the official formula for the mean is the sum of x divided by n. And that's just a shorthand way to say add them all up divided by the number of data. That's just a shorthand way to say that. Okay. Has anybody seen this symbol used that way before? Depending on how much math you've taken, you might have seen this in a few different ways in other math courses. If this is your first time, let's do a couple quick examples. Let's say I give us some data like this. Can somebody tell me what the sum of x is? 18. Can somebody tell me what the sum of x squared is? Like that. So 464? Damn, that was way up. 324?
Yeah.
18 times 18?
Yeah.
Okay. Oh yeah, it was way up. Oh, I went the wrong way. So what's different? What about this? That is not the same thing I asked here, correct? And this is going to come up this semester. So why was this easy up here? Why was that easy? Because they gave you x, yeah? So this says sum up the x's. What does this say? Sum up the x squares. Do you know what the x squares are? Can you figure them out? What are the x squares? 9, 16, 25.
36.
I want that to make nothing but sense. If I have a formula and it says sum of x squared in it like that, and I only know x, just take a minute and figure out what the x squares are. Yeah?
Yeah.
So what's the sum of the x squares? 86. I like it. So what if I ask you, what's the sum of x minus 1? I can make a list of all the x minus 1s, so then I can add them up. Do you see what I'm saying?
Yeah.
So if you see an equation that's got this symbol in it, cover it, say, oh, I need a bunch of those. Go make those, and then add them up. We're going to have many, many equations that have this symbol in it. So if I make a bunch of x minus 1s, I can then do what this crazy thing is asking me to do, add them all up. So what are the x minus 1s? And what do you get? 14. Kind of makes sense. There's 4 numbers. I took 1 away from all, so it's 4 less than the total was before. Or just make this. Okay. I love you guys. Is that okay? Yes?
So the x in the middle lane, how did you get the minus 16?
Oh, what is x in the first row? What is x in the first row? 3. So what's x squared in the first row? Yeah. So this just says whatever's here, square it. Whatever's here, square it. So I gave you all the x's, and then this weird ass answer asked for the sum of the x squares. I'm like, shit, I don't have those. Go make it, and then you can add them up. Okay. I like it. Okay, fine. All this right now is a side note for what's coming later, okay? The mean just needs me to add the x's up, but I figure I want you to kind of have a really good feel for this symbol. Whatever's after it, I have to add them all up. If I don't have them, I gotta go make them. And then I can add them all up. Okay. So that's the population mean. The sample mean has exactly the same formula, it just has a different symbol. So the sample mean has this symbol. It looks like a median that had its hat straightened out. So it's X bar is how you read it. This is red, X bar. So if there was a bar called the X bar, you'd find a lot of mathematicians in there drinking away. All right. As it is, we just go wherever we can. So the formula for this is exactly the way, same thing, because it's the same idea. I don't care. I just use a different symbol. So if I tell you, oh, X bar is 7, you know I'm working with a sample. If I tell you mu is 11, you know I'm working with a population. Just a quick little clue as to what kind of group I'm working with. Okay, look. Of course, the formula is the same because the idea of average is the same idea no matter what group I'm working with. Add them all up, divide by a minute. Okay, so how do I find the middle of a set of data? I can find the average, or I can find the median. Why do we have two things? Because what if I had a company where I had, this is in the thousands, I had these employees making these salaries, yes? I had 3 employees making $32,000, $38,000, $40,000. And then I'm making $450,000 because it's my company. Leave me alone. If a 4th employee was hired and they said, "Hey, how much money can I expect to make?" If you tell them the average salary, is that a good indication for them how much money they can expect to make? What is the average?
38. Average.
The average, yeah. 140? Sorry. 140,000. Yeah. I gotta show it. That's my one skill. So I gotta show that. Huh? Oh, you mean like how to answer that question? Got you. So between the measures of center, average would be a bad choice. The mean would be a bad choice, yes? Milk was a bad choice, okay. What would the median be? So the average, the mean for this, I already forgot, was it 140,000? That would be a bad thing. If you just tell, oh yeah, we average about $140,000. Holy shit, I've been doing it, yeah! And then they get the first paycheck. So what's the median? You can do it. What's the median?
39.5.
Do it again?
39.5.
Nope.
Just 30.
Just 39. Yeah. So right in the middle of these two, 39,000. Isn't that more honest with the salary somebody could expect to be making the first few years? Okay. So this is just like I said earlier about the home prices and the incomes and whatever. If you have outliers in your data, you almost always report the median. It gives you a better idea of the middle. It's not affected by extremes. Which measure of center do we use more often is the mean. But there are specific cases where the median is better. So what are we going to use more often in this class? The mean. So tell me, the median and the mean. Oh, sorry, go ahead.
How do we do this on a calculator? I'm assuming it does it for it.
It does. I'll show you in a bit. The median and the mean, can they handle qualitative data? If I took hair color, could I find the median hair color? No. Could I find the mean hair color? No. So I want a measure of center that could work for qualitative data. So there's a third measure of center, and I heard this word earlier. Somebody said it's another 4-letter word, starts with an M. Mode. And it's the number or the thing that occurs the most. Did I just do that? I think I did. Good job, John. Oh, I brought that dumb light back. Okay, everybody, hold on a second. Part of you went away. Come on. Oh, there it goes. Okay, sorry. Here. So it's the thing occurring the most. The word occurring is weird. So for example, if I went to the parking lot and I saw 5 BMWs, and I saw 30 Chevys, and I saw 22 Hyundais, what's the mode for that data?
Chevy.
Chevy, okay. And that's obviously qualitative data. Chevy occurred the most in my data, so that's the mode. But if I have numbers, of course it works the same way. What's the mode of this set of data? Holy shit. What's the mode for this set of data? What's the problem? Just go ahead and say it. What's the mode? What's the wrong with the way I asked that question?
There's two of them.
There's two of them, I love it, so it's bimodal. Right? Be jealous. There's two things that occur the most. Because who won the prize for occurring the most? There was a tie, correct? So that is bimodal. What about this one? 1, 1, 1, 1, 2, 2, 2, 7, 11. What's the mode?
1.
Or is it bimodal? Yeah, the mode is a clear winner now. So the mode is the most. I think this book talks about trimodal, but I mean, the minute you have more than 3, you're like, there's no mode. So what the mode is trying to do is it's trying to get the center by where things seem to be clustering. So if I grade a test and everybody's kind of grouped out, except I have like 11 people made 78. As a teacher, I go, okay, that's weird. Did they all make the exact same mistakes? And what might that mean? I don't know. Maybe they all studied together, so they all had the wrong. You guys kind of see what I'm saying? So finding where things seem to be clustering is another type of center. Maybe. I love you guys. Yes. There's no symbol for mode. I think one semester we made a symbol for the mode. We just made a capital M. But there's no real symbol for the mode. You just write mode equals or bimodal. Yes? Okay. Okay. So let me ask you this. I'll do a little more. I'm going to let us out a little early, so just hang with me. Here we go. What is the average? Oh, let me do this. What is the average for this data? What's the mean? So your mean, so very quickly, if you calculate a mean and it comes out higher than every data point, can't be right? The mean's got to be.
Yeah, I just divided by 2.
You're good.
Yeah.
So what do you get? 3. So the mean is 3. And what's the mean for this set of data? This set? Sure, JF. What's the mean for that set of data? I'm a Georgia boy, by the way. I was born in Savannah. Right. My accent's buried. 3 also, yes. The mean is 3. Yes? What's the median for both? 3. I could be using symbols, but too bad for me I wasn't. Are both data sets the same? They both have the same mean, they both have the same median, but are they both the same?
No.
What is the key difference?
One has 3 reading.
Yeah, one of them has like several 3s, right? And the other one has distinct ones. So let me say it this way. One of them has data points that get further away from its mean on average. Which set of data has data points that get further away from its mean on average? Which one has, if you think about the mean as home, which set of data had more things that left home? The second one, yes. The first one, the parents are like, oh, what the shit. All right? Those 3 stayed home. And only 1 in 5 left off, went out to find their fortune. And the second one, there's 1 home and then everybody else kind of left. which one, therefore, is more spread out? Second one. Yeah, so if I consider spread to be average distance from the middle, average distance from the mean, then the second one is obviously more spread out. So it kind of makes sense. If I have a whole list of data and I tell you what the middle is, and I tell you how spread out my data is, those are two numbers that summarize 18 million data points in a really nice way, right? I don't want to look at 18 million data points. Tell me the middle and how spread out they are. Yes? You guys semi with me? Okay. So I'm not gonna, this is too big of a thing to get into now, so we're gonna call it a day, but next time I'm gonna talk about what the spread is in statistics. We're gonna develop the formula together, and then we're gonna do some examples. I'll have the quiz created next time. What's happening next Tuesday? Another quiz, you're welcome. What's happening Monday? It's a holiday, yes? Just want to tell you, I know we don't meet on Mondays, but in case you have Monday classes, you have Monday off. Not just because I say so, but because it's some old white dude's birthday. Washington, I think. Oh, don't forget your stuff, please, dear God. Especially your money. I'm going to spend it in Canada.